The 57-million-year-old fossil is both fearsome and comical, a long-beaked penguin that stood 5 feet 7 inches tall and weighed about 220 pounds. It was as tall as a medium-sized man, said Gerald Mayer, a paleontologist at the Senckenberg Research Institute in Frankfurt, Germany, and lead author of a report in Nature Communications on Tuesday announcing the discovery. By comparison, the tallest living species, the emperor penguin, reaches about 4 feet in height. Kumimanu bicei, as the fossil was named, would have towered above the emperor, and above just about all other known ancient penguins. In 2014, another team of researchers estimated that a 34-million-year-old species stood 6 feet tall, but they based that estimate only on 2 bone fragments. Kumimanu wasn't just exceptionally big, it also ranks among the oldest penguin fossils yet found. Both its age and its size make Kumimanu important to understanding the astonishing transformation that turned a lineage of flying birds into flightless swimmers. The 18 modern species of penguin, ranging from the coast of Antarctica to the Galapagos Islands at the equator, are impressively adapted to aquatic life. Rigid, blade-shaped wings enable them to shoot through the water at up to 22 miles an hour. Record-setting human swimmers don't even reach 6 m/p.h. But their adaptations to water have also left them unable to fly. When penguins haul out to rest or rear their young, they can only waddle about on stumpy legs. They're so unbird-like that many people would not know they are birds, Dr. Mayer said. While penguins may look profoundly different from other birds, their DNA points to a close kinship to such species as albatrosses and petrels. These birds all fly over water to hunt for prey, hinting that the ancestors of penguins may have, too. Auks, which can dive over 100 feet underwater, may be a living model of the first penguins. Birds accumulate mutations in their DNA at a roughly clock-like rate, allowing scientists to estimate when their lineages branched apart. Studies suggest that penguins diverged around the time of the mass extinction that struck the planet about 66 million years ago. A combination of massive volcanic eruptions and an asteroid impact are believed to have been responsible for the global catastrophe. Among the victims were giant marine reptiles and dinosaurs, with the exception of birds, which are feathered dinosaurs. The mass extinctions marked the end of the Mesozoic era and the beginning of the Cenozoic, which continues today. The first penguin fossils were uncovered in 1859, and since then more than 50 species have been identified. The oldest of these, found in New Zealand, date back about 60 million years. Known as Waimanu, the oldest known penguins lived just a few million years after the mass extinctions. The new fossil penguin, Kumimanu, was discovered from bones packed in a rock on a New Zealand beach. Realizing that it was almost as old as Waimanu, Dr. Mayer and his colleagues eagerly studied Kumimanu for a better picture of early penguin evolution. To see how it was related to other species, the scientists drew an evolutionary tree and found that Kumimanu and Waimanu belonged to its farthest branches. Their lineages have been extinct for tens of millions of years. By contrast, all living penguins belong to a young branch of the tree. They share a common ancestor that lived only about 15 million years ago. Kumimanu and Waimanu were already flightless, but they still held on to some primitive traits not found in living penguins. Their beak looked much more like a stork's, Dr. Mayer said. Probably they speared their prey. The early penguin wing was not yet the short, stiff blade found on living penguins. They were probably able to bend it a little farther than penguins can today, Dr. Mayer said. There was more possibility for flexing. Where Waimanu and Kumimanu differ from each other is in their height. Waimanus stood just 2.5 feet high. Kumimanu was more than twice as tall. We already knew penguins were around, and flightless, just a few million years after the extinction, said Daniel T. K. Sepka, a paleontologist at the Bruce Museum in Greenwich, Con, who was not involved in the new study. The new fossil shows they achieved immense sizes very rapidly as well, which is cool. Dr. Mayer speculates that the dramatic origin of penguins was sparked by the mass extinctions that marked the dawn of the Cenozoic. Suddenly the oceans were emptied of many of their biggest predators. Penguins could adapt to catching prey underwater without much competition, or fear. It's an educated guess that makes sense, but there's no rock-solid evidence, said Dr. Mayer. One way to test that hypothesis would be to uncover earlier fossils. What would be cool would be to have a flying ancestor of penguins, Dr. Mayer said. The early Cenozoic oceans didn't just open up the way for the evolution of flightless aquatic birds, Dr. Mayer speculated. It may have also fostered the evolution to big sizes. Natural selection favors lightweight flying birds because they have to work so hard to stay aloft. Penguins don't pay that cost. Getting bigger might have brought advantages, as well. A large body makes prey harder to kill. The tree drawn by Dr. Mayer and his colleagues also shows that penguins became giants many times over. While Kumimanu belonged to an early lineage of big penguins, other lineages produced their own giants as recently as 27 million years ago. The rise of marine mammals may have doomed giant penguins. As mammals moved into the oceans and evolved into whales and seals, they may have outcompete the birds. Both seals and penguins need to find safe beaches where they can mate and raise their young, for example. It's possible that the seals pushed the giant penguins out, while smaller penguins survived. The big question for me is not why there were so many penguins in the early Cenozoic, but why there are no giant penguins today, Dr. Mayer said.